looking at an example involving ranked correlation. That person that's unmuting himself, please mute back yourself. I muted you, do not have to unmute yourself. Repeat that, or please mute yourself. Okay, so before I continue, let me ask, were you people able, did you get the research methods?
No, sir.
Okay. One of you should inbox me your email address. Or just send me. Sorry? So? A note, not a recording. Sorry?
The note wasn't required. What it was
okay, maybe one of you should just send me a hi message, my WhatsApp page. Somebody should send me a hi message now so that I can send it to you before I forget.
So when you please send the hi message?
Send to my WhatsApp. It involves rank correlation, and when a question involves product moment correlation. For example, the question we have here, in a debate competition with 10 schools and 2 judges, the following ranks were recorded by judges X and Y. You have the schools and then you have the ranks. And then the question is, to what extent do the judges agree or disagree in their ranking of the debaters? So, now if we fall back to the formula for rank correlation, your interest is in the differences in their rank. The formula is given as 1 minus 6 sum of d squared. D squared is the differences in the square of the differences in the rank, and then n is the number of pairs of ranking, then n squared minus 1. So that gives you the rank correlation. The higher in interpreting rank correlation, the higher the R, the more the agreement in their ranking. The lower the R, the less the agreement in their ranking. These are PLC. Interpreting rank correlation. Interpretation is simply the higher the coefficient, that's the higher the correlation coefficient are, the more the agreement between the two rankings. Like in this question, we have the first one. The result is the first one. The result is 24%. 24 means there's a large degree of disagreement. If you have like 80%, it means there's a strong degree of agreement. Then there's another angle to this. When you have tied ranks, for example, if Judge A gives someone 2 and Judge B gives someone 2, we call that a case of tied ranking. Now, when there are tied ranking, the formula will change. it will become 6 sum of d squared plus t to the power 3 minus t over 12, then into n. Now the t here stands for the tied ranking. T is for the tied ranking. So when there's a tied ranking, the formula changes. But when you're solving a problem like this, just or whether there is any form of tied ranking, because when there's a tied ranking, the formula changes. So don't forget. Now, like the second part of the question is a case of tied ranking. If you check here, at what point do we have a tied ranking? Okay. Okay, so we have tied ranking here, 1 and 2. They are tied. K and L are tied. When you have tied ranking like this, so that's why this is 2. Because the number of t is 2. Then raised to the power 3 minus 2 over 12. And you just resolve it. And whatever happens, know when there are no tied rankings, and know when there are tied rankings. When there's a tied ranking, the dynamics changes. The formula will just change. Okay, so in the case of product moment is for cardinal numbers. So the application is just the same, but the only thing is that in product moment you are looking for something different entirely. You are looking for the degree of correlation between two cardinal data, or the other one you're looking at ordinal data. In product moments, in fact, there are arguments against rank correlation. It doesn't really have much of real life relevance as much as product moments. So what it looks for is the agreement between two different forms of ranking. But in product moment, we are trying to see co-movement, strong co-movement between two variables. For example, in this question, we're looking at co-movement between profit and income. We want to determine whether profits and income move together. So in the light of that, you have the formula here, which also have been demonstrated in this thing. So see the demonstration. Then the interpretation also is that the higher the R, the greater the degree of correlation. For example, the answer we got here is 14%. Though it's perfect, it's positive, but it's not a case of perfect or high correlation. It's small. So the more the correlation coefficient tilts towards 100, the more we can say it is a strong correlation. If it is negative, it becomes a case of negative correlation. If it is positive, it becomes a case of positive correlation. Then the strength of correlation is shown by the size of the R. Like a case of 80%, and a case of 10%. Obviously, there's an indication that 80% is a stronger correlation than 10%. So your interpretation will depend on the size and the sign of the coefficient. The size and the sign of the coefficient. The sign will tell you whether it's a positive correlation or a negative correlation, while the size will tell you whether it's a strong correlation or a weak correlation. So that's there are any questions here. I don't think I have much to say because the examples are quite illustrative and self-explanatory. So this you have any question to raise thus far before I move on. Any questions?
Yes, sir. Hello, sir.
Yes.
Hello, sir. Yeah, I still want to know how in case of the second example for the 32% for the ranking, how they got that T3.
Now, no, 3 is a constant in the formula.
Because
For what you,
okay.
yes, what you get the T here. If you check rank
Yeah.
by X, X had two. Judge X gave two people the same ranking. That's 1.5
Okay.
and
Okay.
1.5. That's the tied.
1.5.
That's the tied ranking. So if you check the first one, the rankings are independent. There's no two persons are tied. No, the first one. No two persons are tied by the same rank as the person ranking. No two persons are tied. 4, 2, 1, 5, 6.
4, 2, 1.5, 1.5.
Is in the second one that now the first example we showed where the rankings are independent. In the second example, we showed where there are tied rankings.
Yes.
So
yes.
In this example now, you see that X ranks K and L 1.5,
yes.
1.5, and that's 2.
Yes.
That's how we got the 2. 2 people are tied.
Okay. If there are three people now to be
these two becomes 3. If there are 4 people, the 2 becomes 4.
Okay. Notice, sir. Thank you, sir.
All right. So I think that takes care of correlation. All you just have to do is to, there are some examples given there. You can practice them on your own. Then use that to strengthen your understanding. Okay, now I'd like us to talk about.
Yes, sir. Hello, sir.
Yes.
All these formulas, are they going to give us for the as part of the question?
No, sir. You're supposed to at least have this formula offhand. I'm asking you to go and copy that.
Huh?
Being able to get the formula is a part of the exam.
Okay. I thought that would be helpful, sir. Thank you, sir.
Alright,
we just put it inside, sir.
That will oversimplify the exam. Alright. Okay, now in the case of regression, remember there's something I told you when I was talking about correlation. If someone asks you to differentiate between regression and correlation, you should be able to do that. But the point, let me make a very important point here. I should get another page. See how it goes. You're still seeing my screen, right? I see a blank screen.
No, sir.
No, sir.
What are you
Concept of
saying?
regression.
Concept of
Concept of regression.
Let me do an issue. You're seeing a blank screen now.
Yes, sir.
Okay, now correlate with Y. It is the same thing as Y correlates X, because there's no impact. If X is moving with Y, it's the same thing as Y is moving with what? X. But when you regressing X is not the same as regressing Y on X. I'd like you to understand this. If you understand this, it will help you know the difference between correlation and regression. In regression is a predictor. We are trying to predict a variable on the basis of the values assumed by another variable. That means it's a measurement of impact. So you are measuring the impact of one variable on another variable. So if that is true, it means obviously the big And there will also be the variable that is being impacted as correlation. In correlation, it's just co-movement. Amaka and Aisha are moving together, hand held. They are moving together. So somebody can either say Aisha is moving with Amaka or Amaka is moving with what? Aisha. Is the same thing. I don't know whether you understand what I'm saying. Are you still hearing what I'm saying?
Yes, sir. Yes, sir.
Yes, sir.
Aisha impacts Amaka. Or maybe Aisha is unemployed. Amaka is earning income. So Amaka provides money for Aisha. Aisha's spendings is dependent on whatever it is that Amaka provides. When we say Amaka is unemployed and Aisha is the one providing for Amaka, so whatever Amaka spends is tied to the money that Aisha makes in the future. So when we are looking at regression, we define ab initio, who is the driver and who is the passenger. But in correlation, there is no such definition. Everybody is a driver, everybody is a passenger. So in regression, the regression of x on y is not the same as the regression of y on x. In regression, when we are saying we are regressing x on y, we are saying that y, regressing x on y means y is explained by x. Now let me write it quantitatively. What it means, what it means is that regressing x on y, that means x is the regressor and y is the regressand. It means y is a function of what? X. Then if you are regressing y on x, it means regressing y on x, it means x is a function of y. So you see, it's a different thing altogether. It now depends on how you arrange the variable. Who is the driver? You know, that's why in correlation, there's no such thing as a dependent variable and an independent variable. But in regression, in this case now, y is the dependent variable. In the first case, x is the independent variable. We call y the regressand, while x is called the regressor. Then in the second case, x is called the regressand, while y is called the regressor. The regressor is the same as the independent variable. It's the same as the impacting variable. It's the same as the exogenous variable. It's the same as the influencing variable. While the regressand is the same as the dependent variable, the endogenous variable, the impacted variable, or the influenced variable. We also call it the cost variable, CAUSED variable, while y is the causal variable in this circumstance. So that's what clearly differentiates correlation from, you may be asked, with the aid of a self-created example, differentiates correlation from regression. It's important to know the difference. When I ask a question like that, as I expect it to be a little bit of a kind of demonstration I have on the screen. Most times I don't trust myself with questions. Sometimes I tell you what the question will be. But unfortunately, some people still feel inspired of that. You know, the reason is that I personally have zero tolerance for exam fraud. I have zero tolerance for exam malfeasance. So what I do, all the help I can give the student, I give it to you in the classroom. That is all the help I can give, all this demonstration, all this discussion we have, and all these pointed questions I'm giving you in a manner that if anybody listens closely, you can even know the direction the examiner is coming from. So, and you have no reason to go and begin to do things that are dishonorable. I consider cheating in the exam very, very dishonorable. It's better you fail honorably than to pass dishonorably. So, if you listen very closely, and then the intention of the exam is not to frighten or intimidate anybody. Just I try as much as I also have a principle. You don't demand from people what you did not give to them. It will be unjustifiable. Be unjust for you to demand from people what you did not give to them. In the light of that, I restrict myself to the discussions I've had with you class, and also what I have pointed out for you to do or pay attention to. So essentially, effort should be made to study. You study and just prepare well. It shouldn't be a big deal. So that is that. Now, let me fall back to what we're looking at. See the extent we can still go to 9. Because I said I was going to end the class in an hour's time. So I have 16 minutes. In 16 minutes I'll be ending this class. So I've explained to us the concept of regression. Then there are 3 ways we can, there are 2 ways actually we can use in fitting the regression line. Fitting the regression line is like a predictor. You create an equation with which you can predict y at given levels of x. You create a line, or you put up a model that you can use to predict y at given levels of x. See, one of the ways to do this by a scatter plot. Now this line you see here is called the line of best fit. It's a line of best fit. It's a line that connects the highest number of these plots, this scatter. So the more of these points you have on the line, the more they fit, the better they fit, the better they fit. The more of these spots you have on the line, the better the fit. And of course, we cannot say this line is a good fit because you have quite a number of the points outside the plots, that's outside of the line. So the more of it, as you can observe, is a trend line. This is a trend line. It shows the trend. And of course, looking at this line, you will know that there's a positive relationship between the 2 variables in question, because the line tends to a positive direction. So that is that. But then, graph does not really show us exactness. It can show us a sketch, but not exactness. That's why there's another method of fitting this line, which is called the ordinary least square method. That's the OLS. So in a simple OLS setting, we make y a function of, when you look at the regression, there are 2 of them. We have the simple regression, then we now have the multiple regression. So when it's regression simple, it's simple. When you have one explanatory variable, is simple when y is equated against one x. X is the explanatory variable. When one variable is explaining the dependent variable, it's called simple regression. Now, also understand that simple regression does not look real. It's not a real life thing. Because there's no way you can tell me that only one variable can impact on another variable and every other thing remains silent or constant. It does not really happen. For example, if you say inflation is affecting economic growth in Nigeria, does it mean money supply is sleeping? Does it mean other interest rate is sleeping? Does it mean all other variables are sleeping? It doesn't happen that way. So simple regression, most times, is just for the purposes of studying them statistically. But when it comes to real life cases, it really doesn't reflect a real life situation, because you hardly can have a situation where one variable only affects the dependent variable and other things are held constant. There are even some variables that can be controlled for, like what we call a control or moderating variable. But that's not within the scope of this study. So what we're just looking at is a case of simple relation where you equate one x against the y. Then you have many regressors. Like in the second case, we have x1, x2, x3, up to xn. All these x are the regressors, and they are all explaining one dependent variable, which is what? Y. And that becomes a case of multiple regression. The multiplicity is not from the point of view of the dependent variable. It is from the point of view of the regressors. When you have multiple regressors, it becomes a multiple regression. When you have one regressor, it becomes simple regression. Alright, so but then there's something we have to look at here. To have have the model in a functional or structural form, in an estimable form, in a form you can estimate. When you are solving regression, you are not looking for the x and the y because they are always given. But you are looking for the coefficient of x, or the x. You are looking for their coefficient. That's the coefficient of the parameters. The parameters are the x, because you are explaining y on the basis of all the x. First x could be interest rates, second x could be money supply, the next x could be inflation, the other one could be trade openness and all that. So you are equating them against economic growth, for example. So all of them are the parameters. The parameters are already given. But what you are expected to do, two things actually. One, you want to fit a model, fit a line, in equation form with which to predict y at given levels of x. And then you are looking for two things majorly. You are looking for one, the constant, and then you are looking for the slope. The constant and the slope. That's the intercept and the slope. Now, the constant is the value of y when all the parameters are held at 0. The constant is the value of y when all the parameters are held at 0. Then while the E1, beta 1, beta 2, beta 3 are the coefficients of the 0.5 x1. You found B2 to be 0, to be maybe minus 0.3. Then you found B3 to be maybe plus 0.12. Then all that. Now this is what your assignment is. The assignment is to get this. Now with this you can predict y. You can now say what will y be when x1 is 20, x2 is 30, x3 is 100. You get the point now. So that's why your preoccupation is not to look for x1, x2, x3. Your preoccupation is to look for beta 0, beta 1, beta 2, beta 3, beta 3. You have to look for the coefficient. That's the coefficient. Okay, now from here you can also decode the kind of relationship between x1 and y. It means that y is a positive function of x1 because this bears a plus sign. It means as x1 is increasing, y is increasing. It also means that x2 is a negative, y is a negative function of x2, meaning that x2 causes decrease in what? Y. And then y is also a positive function of what? X3, meaning that x3 increases side by side with what? Or maybe exerts positive impact on y. So that means the coefficient you find, not only will it show you the size of the change, that's the elasticity of y to every change in x, it shows you the elasticity of y to every unit change in x. Now what this means is that every unit change in x1 will produce 0.5 change in y. Every unit change in x2 will cause y to decrease by 0.3. Every unit change in x3 will cause y to decrease by 0.12, to increase by 0.12. But then this 100, that's the constant, is what y will be if all the parameters are held at 0. Okay, for example, assuming that x1 is 0, x2 is 0, x3 is 0, what will y be? 0.5 times 0 times x1, that's times 0 will be 0. 0.3 times 0 will be 0. 0.12 times 0 will be what? 0. So 100 plus all of these zeros, even minus and plus all of these zeros, that means y will be equal to the constant when all the parameters are held at what? 0. So the simple definition of the intercept, is the value of the dependent variable when all the parameters are held at what? 0. Don't forget that. That's what is called a constant. When nothing is happening, it remains present. You know, there's an analogy I do when I discuss regression. I tell people that in regression we have God and the devil. You know, God is the constant and the devil is the error term. You know, the constant is what is present when every other thing is not there. When all hope is lost, when nothing is present, the only one that can be present when nothing is present is God. And then the only one that makes y not to be equal to all these other explanatory variables will be E. That's the error term. You know, so the devil is the one that tries to unbalance the equation, scuttle everything. While God is the constant, the one that is there when everything is at 0. So I try to explain that because if you were to fit the regression line of life, your constant will be that which is present when everything is held at 0. That's most likely going to be God because it's ever present. Okay, so that's just like that. So, but the next thing here is, how do we get the D0? How do we get the B1? The first formula you have here deals with simple regression. So when you're dealing with simple regression, you have to get the B1 and B0 using this formula. And when you're dealing with multiple regression, this is how you get it. That's B1, B2. I start at B2 because it's a very complex thing, driving it down to B3. But in this day and time, nobody does this. Nobody does this calculation in real life cases. We have softwares, that help produce this result, and they choose to give you a software result and ask you to do the interpretation, and they choose to do that. That would mean in my next class with you, I will do that in the research class. I'm going to bring a regression result, the one I produced by myself. I do analysis anyway, so I produce it by myself, and then we'll do the interpretation. So we'll also look at the one we have here. So that means the option will be either I am asking you to calculate and produce the line of best fit by yourself, or I am giving you an already produced system generated result, and your responsibility will be to interpret the results. So any of those two should be expected. Either I am giving you something you will deal with by yourself and then produce these results you have here, or I am giving you a system generated result. If I'm giving you a system generated result, I'm going to examine you on everything: the R squared, the F statistics, the T statistics, everything. You will need to interpret them. But if I am going to give you what you will calculate by yourself, I may be restricted to a certain point because of the volume of the estimation that may be expected to than you're expected to produce. So in any case, you now know what I have in mind. Either I'm giving you a system generated result to interpret, or I am giving you a question to deal with by yourself, or I'm giving you both. I said I was going to stop at 9, and I would like to stop at 10 rather, as in an hour's time. I'd like to stop at this time. I expect to have more classes with you before your exams. Just be prepared for a no Christmas 2020, because we may have a class on Christmas Day.
Okay, sir.
Somebody is laughing. You're saying, do my Christmas rice, no harm.
We'll not have time during Christmas. So.
There's no network in my village, sir.
I will be traveling and don't network in my village.
No network in my village.
Hey, you change your village.
It's late.
Okay, so bottom line is that I'm not saying I'll have a class on Christmas, but all I'm saying is that we'll have more classes before the exam.
Yeah, thank you very much.
Have more classes. So any questions first, man? I expect you to be reading and be raising your questions as we meet, so that we can be addressing them.
So it's just that these formulas are quite difficult to I don't know, is it to memorize or what? They are too cumbersome. We don't know how we're going to go about it, sir.
Okay. Is it a part of the exam?
Hello, sir.
Yes.
Sir? Hello, sir.
Yes.
Hello, sir.
I
was thinking maybe you use as a palliative for us to give us the formulas.
Okay. In Nigeria, they are fond of stealing palliatives. So you want to cause answers.
So is it for Christmas? Is it as Christmas for us, sir?
So that people will be breaking into the place and store the palliative to remove them. I am going to give you something to solve, like generating the equation result by yourself. It means I will have to stop at some point. But if I'm going to give you the action to do that, it will be no stopping me and go to the end. So in that case, you won't be expected to solve and you be expected to calculate the results. So make sure you go through the board and then be sure you understand the application. You are supposed to be a master's degree student and you're doing an MBA at that, meaning you should sit on a managerial table and then somebody brings results and asks you to lead meaning act on them and make decisions on the basis of those. These are things you should be able to relate to. I know people run away at the sight of figures. There is a phobia for figures. It's not just that these things are insurmountable. People can take them up and keep them in their memory. I know that your heads are preoccupied with a lot of things. So for them, they stay with you. I know the women will talk first. Children, teaching, husband.
Plenty responsibilities, sir.
Alright, thank you. It's fine, let's just be going. To be okay. It's nothing much to worry about. Alright, so thank you for your time and do have a good night, trust. I hope you've shared. Have you shared? Noni, have you shared the material?
Yeah, yes, I have shared the material.
Okay. Alright, I'll stop at this.
Okay,
So
sir.
just be
Thank you,
watching
sir.
out. We'll be watching out for the next class.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you. Have a wonderful night.